Good morning, everyone. So, like I said, um, according to the timetable, today I was supposed to have a class at 7. So, I'm going to record. Yeah, actually, I've started recording, and I want us to just finish up the last question that remained. As I've been told that you guys have a test. Anytime from now, you're going to have a test. So, let's finish up this question, which is on the screen. Yeah, so once we are done with this question, then I'll allow you to go. Okay, so this is the question you're seeing. Yeah, it's a simple question. It will not even take us maybe 10 minutes. It's very simple. So the question says, a block of weight W is suspended from a rope tied to two other ropes at point O. One rope is horizontally attached to a O, and the other is fastened to the ceiling. The angle between the ceiling and the rope is 60 degrees. What are the tensions in each of the ropes? So we need to find the tensions in each of the ropes, and we've been given the angle 60 degrees there. So what are the tensions in each of the ropes? Assume the weights of the ropes and the knot are negligible. Yeah, so the weights of the ropes are negligible. And if the weight of the block is 100 newtons, what is the tension in the ceiling rope? All right, so they're saying if the weight of the block, meaning this weight here, this one is 100 newtons. What is the tension in the ceiling rope? So we have these two ropes. We have T2 and T1. So there's one which is attached to the ceiling, one is attached to the hole. So the one that is attached to the wall is T2, the one that is attached to the ceiling is T1. And we've been asked to find these tensions. So this is a very simple question. Uh, let us quickly do them. Okay, so the most important thing here is to know how to use SOHCAHTOA, is to know how to apply SOHCAHTOA and the rules of vectors. In short, it's just to know how to apply vectors on solving such questions. All right, so let's see what we can do. So I'm going to, if you want, we can divide this here so that you make a triangle there. So if this is a triangle, this angle here will be what? Will be 90 degrees. Okay, let me not divide it from there. Let me just make a Z angle. So a Z angle, we can make a Z angle here. We know that this is a 60 degrees, and then we also have, yeah, so we can make an angle there, 60 degrees. The reason why I'm doing that is because I want to use this angle to find this distance from there to there. Yeah, so rather not the distance, but the tension, which is in this rope. So let's start. So I'm going to take this joint and then I'll draw a free body diagram for this joint. So we have one rope going like that, the other rope going like that, then the other rope going like that. So we're going to take the summation of forces in the X and summation of forces in the Y. So summation of forces in the X, as long as this particle is in equilibrium, the summation of forces in the X is supposed to add up to 0. Summation of forces in the Y is also supposed to add up to what? 0. So when you take the summation of forces in the X we have T2, and T2 is pointing towards the negative. So we're going to have negative T2. So I'm starting with the X. So we have negative T2. And then in the X, do we have T3 in the X? No, because T3 is only in the Y. Yeah, it's only in the Y component. So T3 is not in the X. So what we do is We leave it, we move on to T1. So what of T1? Do we have any component of T1 in the X? Yes, because this T1, we can find the X component of T1 by drawing a line there. So this is T1, this is T3, this is T2. So when you draw a line there, we know that this angle here is 60 from the Z angle that I drew here. So 60 degrees is there. So since this is the longest side of this triangle that I'm going to make is from there to there. It means that what we have here is what? Is the hypotenuse. Then this is the opposite to the angle. So this is the opposite. Then this is the adjacent. So we know to say if you are dealing with the adjacent and the hypotenuse, because the hypotenuse is the one that we're looking for, then we're dealing with the adjacent as well. Oh, sorry, we're looking for the X component of the hypotenuse. So the hypotenuse is given to be T2. So let me just write this as T2. So the hypotenuse has been, or T1 rather, not T2. So the hypotenuse is T1 there. So T1 has been given. What we're looking for is the adjacent. So how do you do that? We know to say when you follow SOHCAHTOA, so from SOHCAHTOA, we can see that the adjacent, we have the adjacent there, and then apart from the adjacent, the hypotenuse. So meaning we're dealing with cos because it's the one that has the adjacent and the hypotenuse. So we say cos 60 is equal to the adjacent over the hypotenuse. So the adjacent over the hypotenuse has been given, which is T1. So we cross multiply here to find the adjacent, which is the X component of T1. So the adjacent is therefore going to be T1 times cos 60. This will be T1 cos 60. So T1 cos 60 is the one that we're going to put there. And because it's facing on the positive side of the X-axis, so we're going to write the positive T1. We're going to write positive T1 cos 60. So this is what I'm going to write there. And then the other thing is, do we have any other X component? We don't have. So if we don't have, we equate this to 0 because we said all the forces in the X should add up to 0. And then since the particle is in equilibrium. Okay, so we also do the same for the forces in the Y. So we sum up the forces in the Y. So in the Y, we have T3. So T3, when you look at T3 there, we have T3 in the Y, T3, and of course, it's pointing towards the negative Y-axis. So we put negative T3 there. And then the other thing that we have in the Y is T1. T1 is also having a component in the Y. So we have something like this. This one 60. So the component of T1 in the Y is what? It's the opposite. It's this one here. So it's facing up because since the direction is like of this vector is like that, it means that you first have to go like this and then you go up. If you want to move from this point to that point, you first have to go like this, and then from there you go up. So the component of the Y component of T1 is the opposite of this triangle. So if it's the opposite, we follow the one that is having the opposite and the hypotenuse, because the hypotenuse we know it to be T1. So we have, so we're going to have something here. I'm going to write something. So we have sine 60 is equal to the opposite over the hypotenuse. So we have the opposite there over the hypotenuse is what? Is T1. So we cross multiply. So we cross multiply there to find the opposite, and this is going to be equal to T1 sine 60. So we have T1 sine 60, that is our opposite. So we have the component of T1 in the y-axis is T1 sine 60. So we write T1 sine 60, and it's facing up. When you look at this, it's facing up. So we write plus, it's facing towards the positive y-axis. So we say positive T1 sine 60. And we say this is equal to 0 as well, because these are the only two components that we have. So from there, what we do is we look at what we've been given here. So we've been given that the weight of the block is what? Is 100 newtons. So this 100 newtons is going to be equal to the tension that is going to be in the rope T3. So T3, in other words, we have been given, it is 100 newtons. Then we say this is plus T1 sine 60. Then we say this is equal to 0. So we take this 100 newtons to the other side of the equal sign, and we're going to have T1 sine 60 being equal to 100. And from here, we're just going to divide by sine 60, so that we get the value of T1. So T1 is therefore going to be equal to, so we say 100 divided by sine, so 100 divided by sine 60. And the answer is 115.5. So the tension in the rope T1, the one that is attached to the ceiling, is actually the one that they are asking us to find. So this is 115 point, let me just write 2 decimal places, which is 47 newtons. So this is the tension they're asking us to find. But we're going to give them a bonus by also finding what? T2. Because T2, they have not asked us to find T2. They said what are the tensions in each ropes. So meaning we find the tensions in both T1 and T2. So it's not a bonus. They are asking us to find those tensions. Okay. So let us find the other tension. So I'm going to write it here because I don't have space. Okay, so how do we solve that tension? It's also very simple. So it's also simple. How do we solve it? So we get the one that has T2 in it. So we have negative T2 plus T1 cos what? Cos 60. We said this is equal to 0. So while is T1 here, we have found T1, which is 115. So let me just make T2 the subject. I'll take this to the other side of the equal sign so that I have negative T2 is equal to negative T1 cos 60. Then when I divide by negative on both sides, I'm going to have T2 being equal to T1 cos 60. So my T1, we found T1 to be 115.47. So I'm going to replace it there. So I'm going to have 115.47 multiplying with cos 60. So cos 60 is a special angle. This is 0.5. So the tension that is in T2, the tension that is in T2 is 230.94. So the tension in the tension T2 is 230.94 newtons. So this is exactly how you're supposed to solve this question. It's very simple and you don't need to even stress to do it. All right, thank you very much for watching this tutorial. So make sure that you don't forget to subscribe to the channel as usual. And all those that are interested in lessons can contact me and I'll see how best I'm going to help them, those that need to join the lessons. Okay, so my name is Amted. See you in the next lesson that we're going to have.